recording with better audio. How's that? All right. So we're going to check for extraneous solutions. Who remembers what an extraneous solution was from their days in Algebra 2? I don't even like the term extraneous solution. I think it's a dumb term. But let's use it because that's what we work with. And I know you guys all remember your Algebra 2 studies, yes?
Yeah.
So what is an extraneous solution? Let me ask you this. What can't X be?
2.
Can it be 1?
No,
Why?
because ln negative.
Domain error, right? So let's call. So what are my restrictions to the domain of this expression?
Greater than 2.
So X has to be, so domain restrictions, we'll put that up here. So X has to be greater than 2. Greater than or equal to 2?
No.
Nope,
Why not, Dawson?
because can't
Dawson.
take the L natural log of 0.
Ah, okay. What about this one? What about this one right here? What restriction should be placed on that? Give me while I shut the door here. What domain restriction should be placed upon that?
Greater than 3 halves.
Greater than 3 halves? Does that make this more restrictive, or does X greater than 2 cover that? Covers that, right? How about this one? Zoe, what about this one right here? What does X have to be for that one? Remember to your graph of natural log. What does your graph of natural log look like? And where does it start? Starts down here, right? And then it goes up there. Now, my arc kind of stinks, so let me fix it. Because does it touch 0? Does it touch the y-axis at all? So like that. Okay. Now, what's the domain restriction on that? That's natural log of x, right? 2 times natural log of x just does a vertical stretch, right? Vertical stretch. So does it change my domain at all? What's my domain as per this graph? What's greater than 0? X is greater than 0. Okay. Is that high? Is that more restrictive or less restrictive than X is greater than 2? Less restrictive than X is greater than 2. So this is really the most restrictive domain restriction that I have, right? So if I get any solution, when I do all that algebra that we learned how to do yesterday, if I get any solution for X that is less than 2 or equal to 2, what do I have to do with them? I got to throw them out, right? I don't consider that a solution because it breaks my expression, right? So, do we understand the premise here? All right, let's get started. Okay, so my restriction has to be X is greater than 2. How do I do this? What would be the first thing that you would do to start evaluating this? What do you think, Henry?
You multiply x minus 2 with x minus 3.
Why do you multiply those? What's your justification? Remember, I have to justify it with the property, right? So, tell me more, Dawson.
That's all.
So what do I write for the next line? What do I write for the next line if I'm using the product property, Ben? Remember, this plus this means I can write it in one natural log, right? Oops. So the left-hand side is going to be equal to the natural log of something. What is that something? Henry?
How do you have x minus 2 times x minus 3?
Yes. X minus 2 times 2x minus 3. So this thing right here, using the product property, the thing I just wrote here is the same as the sum of the two individual natural logarithms. That's product property right there. And this equals, can I apply some logarithmic property? Can I apply a logarithmic property to 2 natural log of x? Power property. So what should I write on that side? Natural log of x squared. I like it. I like it a lot. Okay. Now what do I do? Magic. No, we don't believe in magic. Magic is what snake oil salesmen use to make you part from your money. That didn't sound as good as I thought it would.
Science is kind of magical, science relies on math, so math is technically magic.
What do you think, Liv? What can I do now? I came up with a special word yesterday. It was the one vocabulary word that we talked about. Started with an X, an EX. Close. Exponentiate. Do you remember that word? What base do I want to exponentiate with?
E.
Why E, Noah? Let's be precise in our language. It is the base of the natural logarithm, right? It's the base of the natural log, so therefore I exponentiate using E. So I get E to the natural log of this hot garbage, right? Equals E to the natural log of x squared. When I do that, what happens to the E and to the natural log? They go away. Why? What property will?
What's the question?
What property am I using? So Caleb says that this expression here simplifies to just this times this. And that this expression simplifies to just this. And he's right. My question to you is, what property justifies that?
I don't know.
What feature does e to the x and natural log of x share with one another? Yes, inverse functions. Kian is on point today. Huh. All right, so then I know x minus 2 times 2x minus 3 equals x squared. Now what? Distribute, right? So what do I get, Dawson?
2x squared.
2x squared, stop. Riley, what next? So Dawson did this. I'm going to do that in red.
X times -3.
X times -3, which is
-3x.
minus 3x. So Riley did that. Morgan, your call. What next? So what do I get? Minus 4x. And then, lastly, Ben. What's that? Have I done, have I finished distributing? I've done 4 plus 6. Good. So you did this guy, and that's plus 6 equals x squared. Now what, Lyndon?
Use subtract 4 from -3. -7x.
Okay, good. I'll take that. Minus 7x plus 6 equals x squared. Now what, Lyndon? Let me scroll down. Now what? Sam. Now what? Why did I distribute? Don't I like working with quadratics in factored form? Go ahead, Abby. How do I set it equal to 0? Thank you.
Oh, no.
Nice.
So this is more-
Minus x squared minus x squared. So I get x squared minus 7x plus 6 equals 0. Now what?
We'll circle it, that's the answer.
No, this is not the answer. What do I do now? What's that? No. No. Do we solve quadratics that way?
No.
I could do the quadratic formula, but that's really the hard way of going about this, isn't
Factor
it?
it.
Let's factor it instead. If I can factor it, wouldn't you agree that's easier than applying the quadratic formula? You're too tired, but you're not too tired to snap face.
I'm not on Snapchat.
I didn't say Snapchat.
I'm not on anything.
So, x and x, right? 2 positives or 2 negatives? Which one's it going to be? 2 positives or 2 negatives? 2 positives or 2 negatives?
Thank you.
And then, thanks, Henry. Thanks, Henry. Now what? Zoe.
Distributed just to check.
Oh my gosh.
What makes the equation true?
ZPP,
What is that?
zero product property, right?
Equals 6.
If the product of these two things equals 0, either this equals 0 or this equals 0, right? So now I have 2 things to solve for. I got x minus 6 equals 0 or x minus 1 equals 0. We did this yesterday. Yes, we did.
Yeah.
Yes, we did. If you don't remember, that means you slept, and that means you need to watch the video. With the better audio.
Did not
The
sleep.
video with the better audio.
Yeah.
Now what? Well, x equals 6 or x equals 1.
It's a problem.
Yeah, what's the problem here? X has to be greater than 2. X has to be greater than 2. X has to be greater than 2. So what do?
Stop the wall. It can't be true.
I-86 this guy.
Oh.
This guy goes away, and I'm left with x equals 6. And that is the only answer that I have because I know my domain has to have something greater than 2. Okay? Rest of the time is work time. Took more time than I wanted to there. I apologize. Work day.
90